So we are going to review chapter 2, and there was a lot about linear regression in chapter 2, chapter 3. It is all very closely related. It's just a matter of I have all of these different ways to come up with my equation for the least squares regression line. So how do I know when to use each? Or the different ways to come up with S, and how do I know where I'm looking for S? So the first thing that we're going to talk about here is just how to make a scatter plot. You really do need to make sure you're thinking about which variable goes on each axis. So again, remember, explanatory goes on the x-axis and response goes on y. And then you label and scale your axes, which is really important. Also important here is that you don't need to start at the origin. Again, if your data set starts in the hundreds, then that's appropriate to start in the hundreds. You don't need all this empty space on your scatter plot. Then you're going to plot your individual points. You can make a scatter plot on your calculator using the stat plot menu and then Zoom 9, or you can make one using Statplet. Just know that if a test question asks you to make a scatter plot, it should be a pretty accurate scatter plot. So you should go through those steps of labeling and scaling your axes and plotting those values. If you're just sketching the scatter plot as part of your description, or if you are just sketching it in terms of giving yourself an idea of what it looks like, if you're going to provide a sketch, at the bare minimum, you should at least label the quantities on the axes and make sure that it looks roughly accurate so that you're not deducted points for something that seemingly has no place in your response. But again, if you're asked to make the graph, make sure that it's accurate. When you examine a scatter plot, you have several things that you need to describe. And so when you're describing, keep in mind it's kind of like when we did the SOCs in chapter 1. There are 4 things you need to describe here. You need to describe the direction. So is it positive or negative? Any unusual observations or outliers? The form. So is it linear or nonlinear? If it is nonlinear, you can just say that it's not linear. Or if it's curved, you can just say that it's curved. You don't have to be any more specific than that. And then S is for the strength. So how close do those points fall to that pattern? Even if you say something for the form is curved, you can still say that it's a strong curved relationship if that strength is in fact there. You just don't want to report correlation if it's curved. Correlation is only for linear relationships. So here is our correlation. Remember, correlation is R. Try not to confuse that with coefficient of determination, which is R squared. And that describes the strength of a linear relationship between 2 quantitative variables. So again, that linear is important. Remember, R is always between negative and positive 1. And then the closer it is to plus or minus 1, the stronger the linear relationship. The closer it is to 0, the weaker the relationship. And then keep in mind that you're only going to get a plus or minus 1 if the relationship is perfectly linear. So some facts about correlation. If you switch explanatory and response, we had talked about in the previous lesson that it is going to impact things like S in the equation, but it will not change the value for correlation. And it doesn't have a unit of measurement attached to it. And it doesn't change if we change the units for X or Y. Again, correlation is only appropriate for linear relationships. So if something is curved, do not report R. You can just say that there's a strong or a weak curved relationship. Correlation is non-resistant. So if you have outliers, it can drastically impact your correlation, kind of like that child in the scatter plot in the previous lesson, where it was a very strong outlier or a very large outlier in the X direction, and it really did increase the correlation when we included that point. Here you have your formulas for the slope and y-intercept of the least squares regression line. Remember that these are in your formula packet, so you do not need to memorize them. Also remember when you would use these. You would use if the number summaries are provided. You could, if the problem gave you your X data and your Y data, you theoretically could run one variable stats on both lists. You could run linear regression to get R and then plug into these formulas, but that's a lot of extra work because when you run linear regression, it gives you the A and the B, and you can just write your equation from there. So remember, your least squares regression line is called that because it makes the sum of the squares of the residuals as small as possible, or those vertical distances as small as possible. You should be able to calculate residuals and make residual plots and interpret residual plots. So remember, your residuals is the y minus y hat. Remember, y is the actual point. Y hat is the predicted value that you get when you plug this x into the y hat equation. Your residual plot, it's the scatter plot of the residuals against the explanatory variable. So you've got your original x on your x-axis, your residuals on y. You should have positive and negative residuals, so you will see that horizontal axis through the center of your plot. And so when you are using your residual plot to assess the fit of a regression line, you're looking for a random scatter with no large residuals. If you have a random scatter with no large residuals, that means that the least squares regression line is a good fit for the original data set. So when you're describing that, you do want to make sure you're clear. You don't want to just say residual plot is random and then put like a check mark next to it. You want to say that the residual plot is random, so that tells me that the least squares regression line is a good fit for the data set. You also should be able to find and interpret S, which is the standard deviation of the residuals, and that just tells us on average how far apart the observed and the predicted Y values are. So you should be able to find that from computer output. And again, the smaller the S value is, that means that on average, those points are pretty close to the line, so that's good. The larger that S value is, the further those points are from the line on average. You should be able to find R squared, or the coefficient of determination. Remember, anytime you see fraction of variation or percent of variation, that's always referring to R squared. You should be able to interpret it. So even if it's just plugging it into the context, if I say the fraction of variation in whatever the Y variable is that is accounted for by the least squares regression line, then I'm all set. So really just putting it in context by subbing in whatever the Y variable is to this definition or template. So you should be able to find all of those values from computer output as well, because sometimes problems will give you just the output and not the data. So in that case, you have to be able to read it. So you should be able to find the slope, the intercept, R squared, and S. Again, this is just the two examples that you saw in the previous data or previous set of slides. So remember, y-intercept's always on the top, slope's always on the bottom. Slope is always next to your x variable. We also have the y-intercept in Minitab next to the term constant because it's the constant term in the equation. Over here, this actually tells you intercept next to the y-intercept, and then again, the slope is next to the x variable. Both sets of output give you S, which is the standard deviation of the residuals. So you can see that over here and over here. And then both also give you the R squared. If you need to find R, remember you can just take the square root of the R squared, but the sign has to match the sign of the slope. So always double check whether you need to put a negative sign in. Like I had said previously, we don't need any of this information here at this point in time. So that's all extra. Same thing over here. And then just know your terms for outliers, high leverage, and influential. So again, outliers just don't fit the general trend visually. There's no check. High leverage points are outliers in the X direction, and then something is considered influential if it really changes those numerical summaries. So if removing it drastically changes the slope or correlation or intercept or all of the above. Usually points that are outliers in the X direction are going to be more influential. So if you would like some optional practice before your Chapter 3 test, there are some practice problems here. The solutions are going to be worked out and posted on Schoology if you'd like to take a look at any or all of those.